Alright, so this is just the second part of those notes we were taking yesterday with rational inequalities. So yesterday, everything we looked at was either less than or equal to 0 or greater than or equal to 0. And we didn't have to move anything or combine anything. So today, we are going to look at some problems that we do have to move some stuff. So, here's our first problem that we're going to do. 6 over x plus 3 is greater than 2 over x. Okay, we copied down these instructions yesterday, so if you got them and don't want to write them down again, that's fine. The first two are going to be the ones that we did never do yesterday because I didn't give you problems where they required that. So the first thing you want to do on these is you want to move everything to one side of the inequality so that the 0 is on the right. So the way that I'm going to do this here is I'm just going to subtract that 2 over x. So it's going to look like this. 6 over x minus 2 over x plus 3 is greater than 0. Or if you want to put the minus 2 over x, it's the last. It doesn't matter what order those are in. And then we want to get like denominators and combine. Because we cannot do the chart that we have been doing until it's just one big fraction. Right? So, in this case, that 3 has a denominator of 1. This one has a pretty simple denominator. We just need x on top and bottom. So, that will look like this. 6 over x minus 2 over x plus 3x over x, which I could write like this, 6 minus 2 plus 3x, all over x. I could just write it together. And then 6 and 2 I can combine, so I get 4 plus 3x over x is greater than 0. Questions? This is the stuff we did not do yesterday, but at this point, this looks like what we were dealing with yesterday. So, the next step that you're going to do is you're going to take that you had 4 plus 3x over x is greater than 0. Factor the numerator and denominator and find the zeros that go with each binomial. There's no factoring to do on this particular problem. So we would just find the zeros that go with each expression here. What would they be? There's one that's easy to find. It's going to be the 0. So in the bottom, that x is going to equal 0. The 4 plus 3x is not as easy to find. Negative 4 over 3. So you're going to set that equal to 0. You'll subtract that 4 to move it to the other side. So 3x equals negative 4 and divide by 3. So x equals negative 4 over 3. And so on our number line, we would have negative 4/3 and 0. You can do the chart or you can just plug in whichever one you want. So I'm going to do the chart. So x is going to be negative, negative, positive. Here I will get negative, positive, positive. So that gives me positive, negative, positive for my answers. So for this particular problem, Cade, which ones are our answers, the positives or the negatives? The positives. So we're looking here and here. We would say that's negative infinity to negative 4/3. We're going to use parentheses no matter what because this was a greater than problem. So we don't even have to worry about what's in top and bottom. Then 0 to infinity. Okay, questions? Alright, so that's basically it. We're just going to see some that are a little bit tougher than what we dealt with before. So here is our next example. So we got 2n plus 1 over 3n plus 1 is less than n minus 1 over 3n plus 1. They have common denominators already. You might be tempted to just mark them out. If it was an equation, you could, but you can't with inequalities. You have to keep that denominator. So we're going to move everything to one side first. That's going to look like this. 2n plus 1 over 3n plus 1 minus n minus 1 over 3n plus 1 is less than 0. So even if you have like a big expression right here, you're just subtracting it over to the other side. And in this particular case, we already have common denominators, so we can just combine these. So we're going to have 2n plus 1. Be really careful here because that n minus 1, it's like it's got a parentheses. And you're going to have to distribute that negative. So you're going to get 2n plus 1 minus n plus 1 over 3n plus 1. 0. And finally, we will combine our like terms. So we will get n plus 2 over 3n plus 1 is less than 0. Okay, any questions up to this point? Got it? Alright, so we're going to have n equals negative 2. 3n plus 1, a little more difficult. We're doing 3n plus 1 equals 0. So 3n equals negative 1. N equals negative 1/3. So on our number line, we will have negative 2 and negative 1/3. N plus 2, 3n plus 1, and the answer so if you check each point, you'll have negative, positive, positive, and here you'll have negative, negative, positive, giving you positive, negative, positive. Manuel, which ones are our answers, the positives or the negatives? It's going to be negatives. Always look at what you have right before you start, like, making your number line. So don't look back at the original problem, because there could be times where something has changed here. Always look back at this. This is less than 0, so that's negative. So our answer is here. Since that's just a less than, it's going to be -2 to -1/3. We are going to use parentheses for both of them. Okay, questions? Yes. Only if you were multiplying or dividing by a negative, which is probably not going to happen here unless you just do it to, like, if you have a bunch of negatives and want to get rid of them, you would do that, but you're probably not going to in this case. All right. So for this example, we got 3 over x minus 3 is less than or equal to 2 over x plus 2. We are going to move everything to the left side, so 3 over x minus 3 minus 2 over x plus 2 is going to be less than or equal to 0. We have to get common denominators here. What is my common denominator going to be? X minus 3, x plus 2. So this first one needs an x plus 2. And the second one needs an x minus 3. Remember, you cannot throw the denominators away on this one like we have been doing. So you're going to have 3x plus 6. Right here, when you distribute this 2, what has got to go with that 2? That negative right there. So be really careful there. Negative 2x plus 6. All over, the denominators are the same, so we just write them x minus 3, x plus 2. Do not distribute the denominators, because if you do, you're going to have to factor it back out when you start looking for those points. So just leave it like it is. It'll save you a step if you do that. And if we combine in the numerator, we're going to have x plus 12 over x minus 3, x plus 2, less than or equal to 0. So, CB, what are my points where this numerator denominator is going to equal 0? What will I have? I'm going to put them on a number line. Good. So if I put those on my number line, I've got negative 12, negative 2, and 3. And up here I'll have x plus 12, x minus 3, x plus 2, and then the answer. So just like we did with the others, we're going to fill in our table, negative positive, negative, 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 positive, negative, negative, positive. So our answer here is negative. Our answer here is positive, negative, positive. And Sarita, what are our answers, negatives or positives? Negatives, good. So we're going to look at this point. Now this time we did have an or equal to. Or equal to's tell me that I should use brackets for everything unless they're excluded values. Alright? So, what are the excluded values? What values cannot we not have because they give us a 0 in the denominator? What do you think, Matthew?
Can't have a 3, a -2, or a -12.
Not quite.
Oh, the numerator doesn't matter.
Numerator doesn't matter, so the negative 12 is okay. So when we write our answer here, it's going to be negative infinity up to negative 12. We're going to use a bracket with that negative 12 because it's okay. It came from the numerator. But over here, for negative 2 and 3, both of those are excluded values. They're in the bottom of our fraction, which means they cannot equal 0. So we're going to use parentheses for them, negative 2, 3. And this will be our answer here. I'm going to skip example 3 because you guys were doing pretty well with this yesterday, and I think you got the, I don't think we need to do extra ones, but let's do example 4. Okay, so I need to move everything to the left-hand side. So it's going to be 2x over x minus 5 plus 3. We'll go ahead and put that 3 over 1. Minus 4x plus 1. Is it okay with you guys if I go ahead and factor that denominator while I'm doing this to save a step? So I'm going to have x minus 5, x minus 1. And all of this is going to be greater than. I'm going to put an or equal to on this sign just because that makes it a little tougher, and that way we're covering, practicing those as well. So what should we use as our common denominator? X minus 5, x minus 1. So this one needs an x minus 1. This one needs both. And then the last one does not need anything. And every part of me wants to take my pencil and just mark out those denominators like we were doing on the equations, but you cannot do that. So it's going to be 2x times x minus 1 plus 3 times x minus 5, x minus 1, minus, it's important to put that in parentheses there, 4x plus 1. All over x minus 5, x minus 1, which is greater than or equal to 0. Sometimes this part right here gives students a little bit of trouble. I would suggest multiplying these two right here back together first and then distributing. So for this part, we'll get 2x squared minus 2x plus, I'm going to do 3, and keep yourself some brackets there, or parentheses, whichever ones. You're going to have x squared minus 1x minus 5x plus 5. And then distribute that negative minus 4x minus 1. Don't multiply the bottom together. Leave it factored because you're going to factor it at the end anyway. So, this is going to give us 2x squared minus 2x. When I put these two right here together, I get a negative 6x. And then I've got to distribute here, so I'm going to get plus 3x squared plus 18x plus 15 minus 4x minus 1. Because there was a negative 6 there that I kind of marked out whenever I drew my little line, and I lost it. You were correct. That should be a negative 18. Okay. Now we got to combine like terms. So we've got 5x squared. Let's see. We got negative 2, negative 18, and negative 4. So that's going to be minus 24x. And then we got a 15 and a negative 1, so that's going to give me plus 14 all over x minus 5, x minus 1, greater than or equal to 0. Gosh, I hope that factors. This is going to factor. I don't know. Let's see. Both of them have to be negative. It's got to be a 7 and 2 if it works. I don't think that factors. Let me check it. The 19. Let me see if it factors. I don't think it does. Why did I put this problem on here? I was just assuming that. Yeah, it doesn't factor. The question is do I want to even go further with this? Yeah. All right, let's pretend. Let's pretend without going back and changing the problem so it actually happens. Let's pretend this is not a 24. Let's pretend it's a negative 19. Because if it were a negative 19, then we could factor it. It would be negative 14 and negative 1. So let's pretend that it did factor. Everything on the quiz should factor for you. If we really wanted to do it, we could do some quadratic formula. We could set it all up. It would be terrible, but we're not going to spend our time doing that because everything on the quiz will factor. So let's pretend that this is what we have instead, because whatever you get on the quiz will factor. And I thought this looked like something that I probably knew what I was doing whenever I did it, and also factored, but apparently that was not the case. So we got to get all of our numbers. We're going to have x equals 1. We'll have x equals 5. And then we'll have x equals 14/5, right? I got that 14/5 by saying 5x minus 14 equals 0 and solving that. They do not cancel. Right, we do not. If we were solving an equation, we would want them to cancel. But we don't cancel. Basically, you can't cancel anything in this at all because you need to leave it there unless it might be like a +7 and a -7 cancel if you're adding together. So we would make our chart, which I'm going to have to do kind of small here. 1 14/5 is smaller than 5 and 5, and we would have 5x minus 14, x minus 1, x minus 1, and x minus 5, and the answer so 5x minus 14, it'll be negative until it hits 14/5. -1 will be negative, positive, 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 but so will the next line, and then we'll get negative. So I'm running through that real fast. But you can see, unless it's like 1 minus x, it switches from negative to positive at whatever 0 goes with it. So that's how I'm running through it so quickly. So we would get positive, positive, negative, positive. And so for this one, we're supposed to use brackets, except what are our excluded values? 1 and 5. So if 1 is part of my answer, I can't put a bracket with it. If 5 is part of my answer, I cannot put a bracket with it. Anything else, I'm going to try to use a bracket. So, -infinity to 1 bracket or parentheses. Parentheses because it's an excluded value. And then I would do 1 to 14/5 bracket or parentheses. Bracket right there. And then 5, should I use a bracket or parentheses? Parentheses to infinity. That's not actually the answer to this problem because I made one that wouldn't factor, but I need to go back and try to make it turn out like that if I can. It's so hard to make these questions. And there's not a ton of them on the internet to find. All right, questions on these problems. All right, so